Alright, so in the last video we talked about sort of the steps to go through when doing this hypothesis test for testing for a relationship between two categorical variables. Also showed you the StatCrunch to go along with it. But the one thing we haven't done is actually done an example where we went through all of the steps and also calculated the test statistics. So that's what we're going to do in this video today. So we're going to work with our example here with looking at how feelings about the president are related to having possibly voted for Trump or not. The output that we're going to need is on the next page here as well. So this is what I showed how to get before. So we're going to go ahead and go through our steps here. So the first step is always our hypotheses. And so our null hypothesis is going to be the idea that they're independent or that there's no relationship. So our response variable is how we feel about the president. So the feelings then about the president are independent of having voted for Trump. And again, this idea of independence really just means that we're testing that there's no relationship is our null hypothesis. So in a sense, we're saying there's no relationship between having voted for Trump and your current feelings about the president. Versus the alternative is going to be the opposite. So the feelings about the president are dependent on having voted for him. Or that is our idea of there is a relationship between our two variables. Now notice when we say that there is a relationship here with that alternative, we're not exactly saying how that relationship really is. We're just saying that the one is affecting the other. Alright, our second step is always that decision rule. So we're always going to reject the null hypothesis and believe the alternative hypothesis when our p-value is less than alpha. And our significance level given to us in the problem up there says 1%. So we're going to use that as our alpha of 0.01. Alright, our third step is always our conditions if we're asked for, so we'll go ahead and do them here for demonstration. So we first still have to have the idea of a relatively random and unbiased sample. So if we go way back to the very beginning, where I talked about how this data was collected, we took a random sample of 50 adults from each of the 50 states. That tells us how we collected our samples. So technically that's a stratified sample since we took some from each of the states. It's probably a good thing that we did get things from different states here, so at least from what was given to us, I don't think there's anything biased about how the data was collected. And then our second condition here was just that all of the expected counts need to be at least 5. So we did actually calculate all of the expected counts in a previous video as well. That's what these numbers here that we calculated on page 7. You'll also notice that that's actually given to us in our StatCrunch output as well. This number, each cell format tells us what we're looking for over here. So the expected count is the last number that we had. So I'm just going to write all of these numbers down and state that they are at least 5. So we got the 517.18, the 762.16, and our 81.66. And then in the second row we have the 432.82, the 637.84, and the 68.34. and all of those are at least 5. Our other part of step 3 is our test statistic. Right now we'll just go ahead and list it, and then on the next page we'll actually calculate it. So our chi-squared from my output here is just this 350.327 number. So that's just coming from StatCrunch. Let's also go ahead and take a minute to show how that number was calculated though. So if we look at the formula we had, it was this capital sigma, which remember just means to sum, of the observed minus the expected squared over the expected. And so this sum, if I look up here, I'm actually going to have 6 numbers I'm going to sum. I'm going to have 1 from this box, 1 from this box, 1 here, 1 here, 1 here, and 1 here. So the 2 different numbers I need are my observed, which is the first number listed, the count, and then the last number listed, which was our expected count. So those are the 2 numbers I need for each of my cells. So if I look at my first one, this no approved, my observed is the 298. My expected was the 517.18. I'm going to square that and divide by this 517.18. So that's for the first cell. Then I'm going to move over to my next cell and do the same thing. This time the 987 is my observed, and the 762.16 is the expected. Move over to the next cell, so the 76, and then the 81.66. And now I gotta do the same thing for my next row of numbers. So my 652 and the 432.82. Move over to my next one, to the 413 and that 637 number. And then finally our last cell with the 74 and the 68.34. So that's what my formula would look like. Now let's start doing some of these numbers. So I'm just going to write out what each of these 6 values turned out to be. The first one was 92.88. The next one was 66.33. The third one was 0.39. In my second row, I got 110.99, 79.26, and then 0.47. And if I add up all these numbers, I got 350.32, which is really close to the value we got for our test statistic here. Now this is actually, you can find in one of the options I didn't already show you in StatCrunch. So I'll bring up StatCrunch to show you how we can also get those numbers. So again, I'm going to go to the data options. I'm going to go to the stat, tables, contingency with data. My row variable is having voted for him. and my column variable was your feelings about him. So before I got the row percent and the expected count, I'm also going to add this contributions to chi-squared. So I compute that, I get the same output I had before, except for I have some extra numbers here along the bottom. And if you compare these to the numbers I just wrote out, so 92.89, 92.88, 66.33, 66.33. So those bottom numbers now are each of those individual values that I also just calculated here. So when I look at this output, if I add up these bottom numbers, that's where I'm going to get this chi-squared value as well. I will come back to how that's really useful for me in a moment. So now we're done with step 3. So now I want to do my step 4, which is getting my p-value and making my decision. So my p-value is just part of my output here. So it's less than 0.0001. So if I look back at step 2, is my p-value less than my 0.01? Yes, it is. So we will reject the null hypothesis and believe the alternative. So finally, our last step is to put this into words that make a little bit more sense of what this all really means. So we're going to start with our significance level. Since we rejected, there is going to be statistically significant evidence. To support. Remember, our last thing is our alternative hypothesis, but in words, and it already is in words. So there's evidence to support that feelings about the president are dependent on having voted for Trump. Or in a sense, there is a relationship here. Now, let's talk a bit more about those chi-squared contributions, these numbers that I calculated here, how they can really be useful for me to understand. So I just found that there really is a relationship between my two values. And what we talked about in the last video was the larger the chi-squared, the more evidence that there is a relationship. So if I look at these numbers that I got, which ones are relatively large? Well, 92 is pretty big, 66 is pretty big, 110 is pretty big, 79 is pretty big, but these numbers really aren't very large. And so what that helps me know here again, so the larger these contributions, is what leads to rejecting the null. So in a sense, it's really helping me know where that relationship is. So if I think about that here, if I look at those numbers to see where did those values come from, so this 92.88 came from this no approve area. The 66.33 came from the no disapprove. The 110.99 came from the yes approve. And our 79.26 came from this yes disapproving. So in a sense, it's the approve and disapprove columns where this relationship is really happening. And if I go way back to our very first stuff that we were talking about here with looking at my data, if I look at these pie charts, which ones are different? So the blue pieces look substantially different, where that's where the approve option is. The red pieces also look substantially different, which are disapprove. But the neutral, those green pieces, don't really look that different. So how we're seeing that happen in our chi-squared contributions, these are the neutral ones, those green pieces that weren't very different. Since they're not very different, they're not contributing much to this chi-squared, and thus they're not the reason we're rejecting the null hypothesis here. It's the approve and disapprove columns that are leading us to reject the null hypothesis. And so that completes the first example here of looking at your relationship between two categorical variables.